Alright, we're live. It's a Saturday, February 27th. Let's do today's LeetCode. Before I did. Sorry. Alright, before we start, take a look at any notification. Nothing to see here. Alright, let's go. Let's see if it's going to be a hard one. Divide two integers. Wow, a lot of examples. Let's see. Given two integers, dividend, dividend, and divisor. Divide two integers without using multiplication, division, and mod operation. Return the quotient after divided by divisor. The integer division should truncate towards 0, which means losing its fractional part. For example, truncate this, okay. Assume we're dealing with an environment that could only store integers within the 32-bit signed integer range, okay. For this problem, assume that your function returns this when the division result overflows. It would overflow. Okay, so to write a divide. Okay. I kind of know what this is looking for, but just for fun, we're gonna do it first. Divided by divisor. I think this shall work, but it's cheating. It says the wrong answer. I cannot do a divide directly. Wait, what? What the? What is this? Oh, because it handles the negative differently. Alright. Okay, so we have to handle the... it's fine. So it's going to be ABS divided by ABS. Yeah, so I want to say ABSQ equals this. And the return ABSQ if dividend times divisor larger equal to 0, else minus ABSQ. That shall work. It's still wrong. Oh, the overflow. Very smart. They set up this question so you cannot do this easily. Okay, let's just stop. This is just trying to cheat it, but apparently it's they knew it. They knew it. All right, let's see. So what we cannot use is division, mod, and multiplication. So we have to do it the old way, which is taking the value away. So we have a 10. We have to divide it by 3, which is minus 3. We count once time, and then we minus 3 again. So just count how many times we can do the minus. But this is pretty slow. So what we can do is we minus 3, and the next time we can minus 6. Right? So we put 2. Next time we minus 12, and then we blow up. So we know the answer is 3. The negative value, I think, can the negative value be... Yeah, I think so. 7 minus... we cannot do minus though. Has to be plus. So 7 plus 3. And then 1, 2 plus 6. So that's 4. 4 plus 6 overflow. Therefore, we know we do another one, so it's 2. But it's minus. So 7 divided by 3. Yeah, we can do just a regular divide. Like ignore... Yeah, we do absolute value first, and then we check the sine at the end. What about the overflow? Well, I think there's only one chance of overflow. Yeah, it's this divided by -1 will cause the overflow. I think I've done this before. You know, not on LeetCode, but when programming on the microcontroller, MSP 430. Yeah, I think I did this writing a routine in what's the language? Oh man, it escaped me. Oh man, what's the language are we writing on? No, it's not in C. It's the lower than C. Oh my god. I forgot the name. What's the name of the low-level language? I mean, it's not a low level when it first came out. Assembly! Yeah, that's the one. I remember writing assembly to solve this problem. Maybe we can do an assembly. I don't know. Is it an option? No, it's not an option. Well, I have a lot of other options. I never really took a look. All right, so we kind of got it, right? So the only possibility of overflow is -2 to the 31st divided by -1. This will give us 2 to the 31, which is an overflow, so we just need to return this. So that's a special case. We need to take care of that. And whenever this is 0, we're going to take care of that as well. Oh, maybe we don't. No, we don't, because they cannot be. No, we don't. So there's only one special case. Everything else we just -1, and then we double it, right? Minus double, and we double it again. But when it overflows, right? When we minus too much, we need to add it back, right? So how do we add it back? So say we do 10 divided by 1, right? So we minus 1 first, give us 9, and then we're going to minus 2, give us 7. Now we're going to minus 4, give us 3. Now we're going to minus 8, and this one overflows. So we stay at 4. We stay at 4, which give us 7 already. Then we have 3 left. Right, we have 3 left. Do we have to minus 1 again? Minus 1, minus 2. Because that's the way to handle, like, if you because every time we double it. Or when we overflow, we count back down. Or which way would be more efficient? Wait for it to overflow, or I feel like I did this one before. A similar thing like a multiplication or finding powers. But I just feel like it's not as elegant when we exit it, right? We double, 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 and we get a value that is. Hold on. We do not minus. We try 1. It's too small, and we double it. We try 2. That means have to like 2 times, and then still too small. We double it, and then we double it to 8. Still too small, and we double it again. From 8, we double it again 16. All right, 16. So we double all these times. And then it's too much, right? It's too much. So we go back to 8, and we minus, and then we do it again. Or we can write it as a recursion, right? We go 1, minus, and then we're going to pass in again. This time we're going to do 2. And then we minus, pass in, we're going to do 4. It's smaller. Whenever it's smaller, then we go back to 1. Maybe. Let's try it. But I still feel it's really necessary to do recursion. Yes, I know. Okay, so we're gonna do not recursion. We're gonna do regular until we overflow, and then when we overflow, we switch back to the original dividend. Yeah, I know this sounds very hard to comprehend without seeing the code, but I think we have an efficient solution. So first of all, if dividend is equal to -2, 31 minus 1, and divisor is equal to -1, we're going to return 2 to the 31 minus 1. This is just the edge case we have to consider. Everything else we can write by ourselves. So what we're going to do is we are going to keep a counter, right? And we're going to say while dividend is larger equal than divisor. Oh, we cannot use multiply. So larger equal to something, right? Something. To what? So that is just the divisor plus itself. Let's just give a name, x equals 0. So while it's larger than x, right, then what we do is x equals divisor. Right, so while it's larger than x, we do dividend minus x minus equals x, and then we do counter plus equal counter. No, so counter has to be 1. How do we do counter? Counter is how many times that I have minus x. When minus x once, so counter plus equal to 1. And then I'm going to double on x. So when double on x, counter has to also double, right? But the initial value of the counter has to be 0. So if counter is 0, so counter is going to plus equal 1 if plus equal counter if counter else 1, right? And then after we do this, x is going to double. X is going to double. And then we're going to keep going until we fail, until our dividend is, so dividend with minus this when we update counter and x double, and then it's out, then we can return counter. But this also depends when dividend is smaller. So when dividend is larger or equal, and now dividend is smaller than x, right? Dividend is smaller than x, then what we need to do is we need to run divide again. So we're going to return counter plus self.divide. So it's going to be current dividend, dividend or dividend. Anyway, it doesn't matter. And then call it divisor. I hope this is right. I'm not sure. I have a feeling. Let's try. 10, 3 have to return 3. 7 minus 3 has to return minus 2. Oh, we haven't even considered that yet. My God, this is not looking well. And 1, 1 is going to be 1. Now we haven't even considered the minus situation yet. Man. How do we do this? I have an idea. So this is, we might not even have to. So like we can put this as a special case when we return, right? When we return, and if it overflows, we are going to return a different value. So we have this value. Yes, okay, so we don't need this. We are going just to say we don't need this. So counter is this, right? And we're going to have a sine equals 1 if hold on. My dear Lord. So if they're both negative, so we can just turn them into positive. If one is negative, then we just turn the sign into negative. Okay? Okay, I think this should be fine. So sine is if dividend time. Oh, we cannot use times. If dividend is larger than 0 and divisor larger than 0, because I'm using minus, right? So it cannot work. It has to be plus if one of them is negative. And this, yeah, all depending on both are positive. Yep. Okay, so we have to decide. We'll decide when we return. So what we're gonna do is we're gonna call div. Oh, both are, so dd is a dividend and ds divisor. We're gonna do ABS on both. ABS does not use those things. We have the counter, we have the divisor, and if the dividend is larger, and then all of this is the same. Dividend, counter, x, and then we have res equals counter, and this is going to be dd, right? dd and ds. And when I do one, this is fine. So when we end everything, right? Now we're gonna check. We're gonna say if res is equal to, res is larger than 2 to the 31st minus 1, which means we overflow, then we're gonna return 2 to the 31st minus 1, which is a value, which value? I just, it's fine. Actually, no, I want to just spell it out. So it's just going to be a value, so you don't have to do the computation, okay? Else, now we're going to check on the sign. So how do we check on the sign? So we say if dividend is larger than 0, larger equal than 0, and the divisor is larger than 0, or dividend is smaller, dividend smaller equal to 0, and divisor is smaller than 0. So this is our condition, and I'm going to put 2 parentheses on it so it makes more sense, right? And then we return res, else we're going to return minus res. So it's trying to avoid using multiplication as much as I can. And we can give a shot now. Oh man, I spelled it wrong. This is a divisor, and this one will be divide dividend and the divisor. Too many values to unpack. I forgot to put an answer in it. Maximum recursion depth. How is maximum recursion depth hit? What what the hell? Oh, not ds. It has to be divisor. It's not gonna be divisor. It's gonna be. No, yeah, it is ds. It is ds. Because ds did never change. What changes x? But it says it just keeps going. Why? All right, let's put it in 10, 3, right? 10, 3. So 10 and 3, counter 0. X is 3. 10 larger than 3. 10 minus 3 is 7. Counter is 1. And x is 3. Now x is 6. Going back. 7 minus 6 is 1. So dd is 1. Counter half count, so counter double itself. Oh, counter double itself. It cannot double itself. Counter has to be increment, like add counter times 2. No, not counter times 2. Not counter times 2. It's the. Oh man, I can't. I'm trying to reason this. Okay, so we need to have a counter, and we need to have a counter, and we need to have a quotient. I think we need 2 things: have a counter and have a quotient. So both 0 to begin with, right? So a counter plus counter if counter else is 1, and then quotient always add a counter, and then res equal. So now dd is 1 and x from 3 to 6. Now it's 12. 12 is too big. dd is too big. So I quit. So dd is 1, and this is 3. So it's not going to be counter. I'm going to get a q. Okay. And then we're going to divide 1 by 3. So this should give us 0, which will go here. Go to the next one. 1. That's false. So we have res. Res. Oh, I keep calling it. Ah. Okay, so we have to have an anchor case. We need to have an anchor case, which is if dd is smaller. Now we don't have to. Anchor case could be like this. plus this if dd is larger equal to ds, else this is 0, right? Not enough to unpack. Oh, because I forgot to do it here. 0, 1 is going to be 0. Well, we have some pass, some fail. So everything returns 0, which is not correct. Okay, let's focus on this. This logic is so convoluted. It makes me feel very uncomfortable. Give me result is 0. What the heck? Plus this if else. Okay, I think it's because we need to put the parentheses here. Okay, so I put a parentheses. Yeah, it passed now. Now everything passed. Okay, I think is it possible to make it even better? I have a little recursion here, and we have a check, and we check also for the sine. Check for the sine, check for overflow, and this is the first round, and then I'm gonna add it again. Do we need both a queue and a counter? So the counter is to count how many times, right? The queue, I think queue can just add plus q times 2. No, it cannot be q times 2. It's the number of times that we have done it. The number of times that the dd that we have increment x, right? So it is a counter, but probably don't call it counter because I want to make it a little bit short. Let's call it C, right? It's a C, it's a counter. And then this is just a counter. And every time x doubles, counter doubles, x doubles, quotient has to increment based on counter. And when we're done, we have the current quotient and we need to add whatever is left. Now whatever is left is determined by another divide. Another divide is the current remaining, right? The remaining, and we're going to divide by ds as well. And once it's done, which this shall only do one time, I think, 1 or 2 times, so it won't recurse too much. All right, let's try this. I think this one shall work. Pending. Oh no! Oh, I see. I see. Have to do this first. So have to do this. If this, then res is a positive. And then I'm going to say return res if res is larger than 2, 1, 4. Res is larger than this. Else return res if res else. We're going to do this. So if it's negative, then we should be fine. So we have minus 2, 1, 4, 7. Oh, I can actually do it here. 8 divided by 1. This one shall return this. However, yeah, it was my issue. I did not handle it very well. So this is the other case. Yeah. Wait. What? Oh, because everybody is. Oh my goodness. No. Why would the result be this? No, if it's smaller. Ah, dude, man. This one has to be here. The rest has to be here. Okay, not 100% correct. Number 4. Oh, number 4. I got wrong. It's going to be minus. There we go. Okay, this shall work. This shall work. This shall work. Come on, pending. There we go. This one works. Oh, we got 20 milliseconds. Wow. 99.5%. Which means the solution is correct. You know, the performance is pretty good. Okay, so this is how should I explain this? Okay, counter. Oh, I know. They say no multiple, but I can use. I know. I can use mask. I can use a mask. Yeah, I can use a mask. So instead of doing this, I can use a mask. But I guess it's fine. A mask is we're going to check on the. We're just going to check the first. We're going to check the first. The not least the most, right? The most bit. The largest bit. How do we check the largest bit? We can check it by AND it. Oh, not AND it. We're gonna OR these two values. OR them, right? We OR these two values. Yeah, we OR these two values and run a mask and to see if the value is 0 or not. Which means, I think what we can do is we can do dividend, OR divisor, right, with all these two values, and no, not OR, it's exclusive OR. It's exclusive OR. So we exclusive OR these, and we're gonna hit a mask. A mask is going to be 2 to the 31st. Right, 2 to the 31st is the mask. Yeah, 2 to the 31st is 1 0 0 0 0, all zeros. And when we do that, this one, if it's not 0, that means it's going to be a negative. So we say if it is 0, that means it's a positive value. So we can make it a little bit easier. And since we're doing this, let's just use it. -1. Right? No, that is not correct. Is it not right? This is exclusive OR, right? I actually don't know if it's exclusive OR. Let's run some experiment. Yeah, let's be a little bit fancy on this. So let's say A is 1 and B is -1. A exclusive OR B is -2. Yeah, A exclusive OR B if I AND 2 to the 31st. It is. Wait, what is this value? So maybe do I have to do this? No, you don't have to do this. It's what's the binary value of this? Yes, that's correct. That's correct. And because that's so okay. So what if I do B is also 1? This shall give us Why is the end? Hold on. I thought we clear everything. Yeah, we clear everything, right? Hold on. I think like there has to be here. There we go. Oh, I know. It's because this one does not take precedence. So we have to do this as precedence. And there we go. This is correct. Yeah. I use a little bit trick here. I just want to say overflow. Overflow equals this. Right, and then both of these can be swapped with overflow. Right. This is a mask. So overflow is here. Mask is so when you do mask, okay. So this one pass. The solution is the signage is that how you call it? The sign is pretty tricky to handle. Therefore, so we do not handle it when we actually perform the division. This means we will perform ABS on both dividend and divisor. During division, we take away divisor from dividend. Each time we can perform a takeaway, we double divisor. This speeds up the division process. We continue until the remaining dividend is smaller than the current and enhanced divisor. When this happens, we run the function again by passing in the smaller dividend and the original divisor. The quotient is the number of times the divisor, the original divisor, has been taken away from the dividend. Right. Now, once the positive value division is complete, we think about the signs. We can use a bit manipulation trick to get whether the dividend and divisor have the same sign. And finally, the only chance of overflow is when the quotient is 2 to the 31st, which is caused by minus 2 to the 31st divided by minus 1. We check this special case before return. O log dividend, and it's a log dividend, right? Yeah, I think it's, no, it's not log divided. It is log divided. I don't know. Or is it log divided? I think it's all log divided. And then we run 20 milliseconds. Well, this one probably is not going to run 20 milliseconds. This one probably going to be a little bit slower. Let's stay true to our stuff by run it again. And let's see how long this one takes. Yeah, this is more likely. 32 milliseconds. And give us 67% ranking. Alright, let's go back to the question and see what are the other better looking solution. I think the solution shall be about the same. I don't really see there are any better, like in terms of the runtime. I think this is the standard runtime for this. So we're going to just take a look. That's very low passage. Oh, a lot of people don't like this question. I like it because I passed it. Have I done before? Oh my goodness, I've done it before. Oh wow. I've done it. Time limit exceeded. Oh wow. Well, I did have 3 wrong answers. Well, but that's just for fun. So we done it about like half an hour, I think. Ooh, yeah, I've done it before. It should not use long int. Yeah, they probably just, yeah, you cannot use long int because you cannot store the overflow. Clear Python code. Bit manipulation. Oh man, that's sine. Oh man. It's a lot of shift. Subtract by shifting 3 to the left by 1. Oh, it's yeah, shifting is multiply. Again. Okay. We can most subtract from 15. Okay. 4 times 3. We add 4 to the answer. The above process like we now get part of the quotient. Then we repeat the above process by subtracting. So, oh, okay. So they, instead of running recursion, they do it inside, right? We can, instead of doing this, we can just shifting. So we shift and shift, answer plus. Oh, that's the count. That's their count. Oh, we can do shift. Okay, so I think the only thing I want to change is, did they take ABS? Yeah, they do take ABS. They have to take ABS. They take ABS. They do the sine. Oh, look at this. Larger than 0. Oh, 1, 1. Nice. Oh, nice. This is a better one. A better one. And if it's smaller, I just terminate it. I should probably do it at the beginning. All right, let's do it again. I mean, the solution is the same. I mean, there's not that much to go with this. How do you handle the? Oh, it handles here. It handles at the beginning. Give me some thought. Maybe we should handle at the beginning as well. Apparently, handle at the beginning can make the remainder of the code easier. Alright, so 2 things. We have overflow and mask. So these can be done at the beginning, right? Which means we're going to just do it at the beginning, right? So we're going to do it we're going to do this, and we're going to hit it. We're going to say if, I like to do it at the end. Should we do it at the beginning or should we do it at the end? I mean, we can do, let's set up overflow and mask over here. We don't need this mask actually if we're using their method. So we're going to say if dividend is equal to minus overflow, no, is equal to actually overflow minus overflow plus 1, and divisor is equal to minus 1. We're going to return overflow. So this is the edge case. And we run to AVS, and then we say if dd is smaller than ds, we're going to return 0. So these are the edge cases. And then we go into it. We have the count, the quotient, and we don't have to use this anymore. But we do because we need ds. We cannot change. We need the original. But we can do a divisor again, right? So we don't need this. Oh, we cannot. Oh, we can because ds, we already have it. We have the absolute version of it. So we say if this is larger than ds, oh, if it's larger than ds, then we can return q. Larger than ds. If it's smaller than ds, we do this, right? If it's larger than ds, we are going just to return, yes, right at first, and larger than ds, we're going to minus ds, and instead of this, we're going to see just shift left by 1, and ds is going to shift left by 1, quotient plus, right? And then we don't have to do the check here because we did the check earlier. So the result is this, and now we're going to see the sine. So the sine, we don't need mask. All the sine we need to do is the dividend is larger than 0. If it's true, then this will return 1. And we're going to do divisor larger than 0 as well. So it's either 1, 1 or minus, or 0, 0. So they can give us 0, which means if this one is not 0, and then we return a minus res. Minus shouldn't be like q. Yeah, we can just do q. Why do you have a res? Q plus equal to this. And then we just return minus q. And else we just return q. So we can return minus q if else we return q. So we further make it further shorter, right? Like this. And we probably have to say overflow has to be like self dot, like this. And try it. It is not correct. Okay, something is not right. Do we have to put special? Let me see. This should be right. And this should be okay. We pass on test 0, 1, 2, and we pass on this because these are the special case. We fail on the first one. Let's take a look. So this is not going to be affected initially, so we have 10 and 3. 10 is not smaller than 3. We go here, CQ, that's good. So DD is larger, that's true, and DD minus equal to DS. So 10 minus 3 is 7. C becomes 1. And DS becomes, left shift 1, so DS becomes 6. Q now is 1. And we're going to go up, right? Go up. What do we have? Oh, DS has changed. DS has changed, so we have to be divisor here. This has to be divisor. Nah, it's actually not divisor because this has changed. This has to be AVS divisor. Cannot be divisor itself. Well, is it possible we do it without, right? We do it without using recursion. I mean, I think if we do this, it's still not correct. Even if I do ABS divisor, it's still not correct. Why is that the case? I have the ABS divisor is what? Is 3, right? And then we have, when we quit, DD is 1 and DS is 6. And we quit. And then DD is 1. This is 3. So we're coming in. We shall return 0. So Q, I do not understand, but I am going to just print Q. Let's see where things go wrong. Q is 0 initially. Wait, C does not increase? How? Oh, I have fallen 0 shift 1 is still 0. Oh my god, so C cannot be. Oh, I know, C has to be 1, but we increment before and then do this. Now it becomes minus 3. Unbelievable. Why? Dividend, that's true. That's 1. And then this is also 1. And this is 0. If 0, no, we return Q. Why would be minus 3? Let's see what we have. Yeah, it's 3. I think it's this part is not right. True is 1, right? Okay, 1 larger than 0. Exclusive or 2 larger than 0. We have false. Yes, it is false. So we return Q. Okay, let's do it again. It 1 if else 0. Return 0, yeah. How? Divisor, dividend, and divisor. This have not changed their value. No, they're not changed. Oh, wait, this is true. Why? How come this is true? How come this is true? What? 10? 3? Oh, I think I know. Precedence. I probably have to do a parentheses here and a parentheses here. Yeah. How is it possible? Why is this has the same precedence as these? Huh, I guess it's possible then. Okay. So this is still the recursion solution, right? We want to see if it's possible to do it without recursion. So it's basically almost tail recursion, so we can turn it into a loop. So we have DD and DS, and DS has decremented. So while DD is larger equal to DS, we shall do a temporary value for DS. So we can say temp is equal to DS, and we say while dd is larger than temp, and we have temp going through all this. So we're going to minus temp. Q is increment, increment, and temp is going to do this. And then when it exits, right? When it exits, we have the Q, and we have the C, and we have the temp. And we're going to check, right? We're going to check whether, no, we don't have to check. We just get C back to 1 and get that's end it today. Have emergency. Bye.